Concavity of parametric curve, concavity, you have to use the second derivative. So up to this moment, we discussed the first derivative. Graph of a parametric equation. Graph of parametric equation, you choose the value of t, and then you plug in the t to x and y, you plot all the points, and then you connect them, draw the orientation. The first derivative refers to the slope. So for the slope, you have to pick a point on the parametric curve, and then you have that point, and then you have the corresponding t value to that point. And then, so what you have to do is you plug in the t to the first derivative equation, and then you find out what the slope is. With the slope and the point, you can use a point slope form to build equation of the tangent line. And then when it comes to the second derivative is the derivative of the first derivative. Okay, then I will be doing the second derivative. So that is in differential calculus. Derivative is dy dx, right? The derivative of y with respect to x. When you reach to the second derivative, you take the derivative again with respect to x. So you take the derivative with respect to x again of what? Of the first derivative. The first derivative is dy dx. And then for the dy dx, again, this is for parametric. So for parametric, the y is in terms of t and x is in terms of t. So what you have to do is, we already know what dy dx equals to exactly. You have to put the dy dx in up here. The dy dx stays here. And then the pink d and the dx, that stays right there. And then without moving further, do we agree that from this point to this point, I didn't change anything? So the dy dx, once you flip this back to the numerator, the dx goes back to its original place, right? I didn't change anything. The dy dx, so once you multiply the reciprocal of this, and then the dy dx snaps back to its place. Okay, and what is missing in there? Remember, they are with respect to t. Okay, and then I need to add the dt in there. They are with respect to t. And then this one, the dy dx, the dx dt, I will just use what I got from the previous video. If this is your first time watching this video, just look at your problem. Your problem is asking you to find the concavity, right? And you don't know how to do it. That's why you are looking for a video to watch. Okay, the equation gave you x in terms of t and then y in terms of t. You find the first derivative first. So you find x, the derivative of x with respect to t, the derivative of y with respect to t, and then you put the dy above the dx. Then you will get the purple dy dx. Okay, and then of course, you have to take the derivative with respect to t. And then I will just recall from the previous video. So I'm going to recall from the previous video. My dx dt is equals to 1 divided by 2 times square root of t. If you are doing your homework, you have a different answer, then just fine. Just look for this in your first derivative. And then dy dx equals to the square root of t to the third power. Okay, then we plug in everything we know. Okay, then we draw a long fraction bar, the dx dt. I got that is 1 over, I should put that in, keep that in purple, 1 over 2 times square root of t, and then the dy dx, that is the square root of t to the third. Okay, should I use square root? Okay, I will just do how about 3 over 2 power, and then the d dt, I will just leave it as it is what it is. Okay, it is what it is. I will just duplicate, just put it right here. That makes sense because I have t. I can take the derivative of the purple with respect to t. Okay, then what is that equal to? That is equals to the derivative of that. You bring the power down, and then t to the 3 over 2 minus 1, that is a 1/2. And then this is a 1 over 2. And then this is a 1 over t to the 1/2. And then you have both over 2, so the 2 is gone. And then that is equals to 3. And then t to the 1/2, you flip that to the top, and then you have a t to the 1/2 again. And then this one, you have a 3t. And then what is this represent? This represents the concavity of parametric curve at t greater than or equal to 0. And then for the parametric curve, so this is based on my previous video. The parametric curve that I use for that is x equals to square root of t, and then y equals to 1 over 4 t squared minus 4. And then I restrict t must be greater than or equal to 0. And then if you want to plug in some numbers, so let's say let's plug in some numbers to play around with this. How about this? And then also if you are following the video along, there is a table value, and then I will just say from the green table, because I use green to draw the table. And then when t is equals to 4, the x comma y is equal to 2/3. Let's find the concavity. And then this one I will just plug in. So the second derivative that is 3 times 4 equals to 12. That means at this point on the parametric curve, the graph is concave up. Parametric curve is greater than 0. Sorry, greater than 0. So the parametric curve is concave up. I should be more clear. Greater than 0, positive. So the parametric curve is concave up. And then let me scroll up to my previous picture. At this point, the graph is concave up, and then you can see that is very clear. If the problem is asking for a different point, then you need to plug in a different t. And then well, if you are doing another specific problem, make sure that they will give you a t, and then you plug in that t to the second derivative to find the concavity. Okay, so that is all I want to discuss in this video, and then I will see you in the next video for some arc length.